Okay, this is 8th grade lesson 4.3. This will actually be a really quick lesson based on what we did for the activity. You learned a lot of your information that you needed to from the activity. So our objective today is students will write linear functions by recognizing patterns in graphical as well as table information. The standards covered in this lesson are going to be 8F1, 2, 3, and 4. The hardcover book, pages 162 through 167, and our practice journal is going to be pages 85 through 88, which we used a lot of those in our activity. Okay, so this is just going to be a quick review based on what we had done with our activity. A lot of this information is going to kind of just fall into play. So here we've got a real world scenario. It says the table shows the cost Y in dollars of renting X movies. So the first thing we need to understand is when we go to graph this out, if we're graphing how many movies we can we rent partial movies? Can we rent a part of a movie? No, we could not. So when we do this, we're going to do a discrete graph, okay, which means we're just going to be doing our dots, right? So when we go to graph this, there will be no line. So it says graph the data. Is the domain of the graph discrete or continuous? So we just discussed out that it would be a discrete graph because we cannot buy a part of a movie. Write a linear function that relates your Y to your X, and then how much does it cost to rent 3 movies? So they didn't have 3 movies in there. So we're going to go ahead and graph our information. You guys will use your whiteboard graphs. I just went ahead and copied a graph. Hopefully it's big enough. So when we go through to graph these, I'm going to go over to 0, up to 0. So over to 0, up to 0. So 0 movies is going to cost $0. And I'm just writing on here my information. Okay, so if I get 1 movie, it's going to cost $3. So that one's graphed. 2 movies is going to cost $6. And 4 movies is going to cost $12. So that's going off of my graph. I'm going to kind of guesstimate approximately where it would be. Okay, so there's my graph. So we need to write our linear function. So we've got Y equals, okay, our slope is, our rise is 3 over 1. So it's going to cost 3 over 1 or $3 per movie. So 3X. And it crossed at 0. So we started with 0 movies. Okay, so Y equals 3X is our equation. We don't even need to have that plus 0 on there. So we're going to pay $3 for every X or every movie. That's what this equation is representing. Okay, so the next part says, how much does it cost to rent 3 movies? So we're going to go ahead and substitute in 3. And a lot of you, common sense, without even substituting in, have probably figured out the pattern. I paid 3, I paid 6, now I'm going to pay $9. So we would pay $9 to rent 3 movies. Okay, if I asked you how many you would rent, or how much it would cost you to rent 10 movies, well, you wouldn't have to graph all that out. You could substitute in a 10 or X's, and 3 times 10 would give you $30 is what it would cost you. Okay, so once again, we're not going to connect our dots. We're just going to go ahead and leave it as dots because it's a discrete. We cannot buy a partial movie or rent a partial movie. Okay, so here's our next one. They want us to write an equation for this one. So we don't have a table here. Could I create a table? Sure. I'd go over to -2 up to 3, or it would look like this if I set it up in a table that you just got done with. Over to -1 up to 3. Okay, over to 0, up to 3, you see the pattern. All of our Y's are equaling 3. So where does it cross? We've got our slope X, and then where it crosses the Y line, it crosses at +3. What is our slope? Our rise is nothing. Our run is 1 or unlimited. This would be 0 X's, which is gone. So our final answer is Y equals 3. Okay, we don't have a slope there, so we just leave it. And we graphed these clear back at the beginning of the year. So some of you maybe already remember that and didn't even have to go through this step of it. Okay, one more. So here we've got one more scenario. So we're going to go ahead and write. We don't know what this scenario is representing, so your choice if you choose to connect the dots or not. So we're going to go over to -2, down to -4 and put our dot. Over to -1, down to -2. Over to 0, stay at 0, and then over to 1, up to 2. So there's the points that they asked. So now we're going to go ahead and write our equation. Y equals our slope. Well, our rise was 2 over 1. So it'd be 2x, and it crosses the y line at 0, so plus 0, or you can leave it as just y equals 2x. Okay, so once again, because of the amount of stuff that we did in our activity, a lot of this is going to be review from stuff that we did back in chapters 2 and 3. Just understanding that our y-intercept equations are actually function equations, and they actually go hand in hand. It's just another word, another type of wording, a play on words. So y-intercept equations are actually representing functions. Function is just a real world scenario where we can go through and actually solve some different situations. So that's pretty much it for this lesson. Good luck. And just remember, when you write your y-intercept equation, you've got y equals your slope of your line, and then where it plus or minus where it's crossing the y-intercept.